Today, we're going to pull back the curtain on something amazing, a powerful tool that physicists use to check their work, to make sense of the universe, and, get this, even to guess the laws of nature. It's their secret weapon, and you're about to see just how powerful it really is. So picture this, you're looking at a page full of really complex formulas. I'm talking orbital mechanics, fluid dynamics, the heavy stuff. Now, what if I told you there's a way to spot a mistake almost instantly, even if you completely blanked on the specific physics law it's supposed to describe?
It honestly sounds like a superpower, right? But it's not magic. It's a beautifully simple and logical technique called dimensional analysis. And it all begins with understanding the absolute basic ingredients of our universe.
To really get this, we need to stop thinking about numbers for a second and start thinking about the fundamental nature of things. What are physical quantities actually, made of?
It turns out that pretty much every physical quantity you can measure, from the speed of a car to the energy of a star, is built from just a few core ingredients. The big three are mass, which we'll call m, length, which we'll call L, and time, or T. Just think of them as the universe's basic Lego bricks.
And here you can see exactly how that works. Let's take velocity. What is it? It's just distance divided by time, so its dimension is length over time, or LT minus 1. What about force? Well, that's just mass times acceleration, which breaks down into MLT minus 2. And energy? That's just a force applied over a distance, giving us ML squared T minus 2. See the pattern? Everything, no matter how complicated it looks, is just some combination of M, L, and T.
Okay, so we know everything is built from these core dimensions. That understanding leads us to one simple, completely unbreakable rule that makes this whole technique possible. It's the key to everything. And here it is, the principle of homogeneity. Now that sounds pretty fancy, but all it really says is that for an equation to make any physical sense, you have to be comparing apples to apples. Both sides of the equal sign and every single piece being added or subtracted has to have the exact same combination of M, L, and T.
And this really just boils down to common sense. You can add 5 meters to 2 meters and get 7 meters. No problem. Dimensionally, you're just adding a length to a length. But what happens if you try to add 5 meters to 2 kilograms? It's nothing. It's complete nonsense. You can't add a length to a mass. Any equation that tries to do that is just fundamentally broken. So, we've got our Lego bricks, and we've got our golden rule. Let's put this thing to work and see how it lets us check and even decode equations we've never even seen before. All right, let's take a look at this equation. F is force, V is velocity, and T is time. But then we have these two mystery constants, A and B. We have no clue what they represent physically, but you know what? It doesn't matter. We can figure out their dimensions right now.
Okay, let's walk through this. First, we already know the dimension of force on the left side is MLT negative 2. Now, because of our golden rule, that means the AV term has to have that same dimension, and the BT squared term, you guessed it, that also has to be MLT negative 2. From there, it's just a little bit of algebra to figure out the dimensions of A and B on their own. And just like that, we've learned something fundamental about this equation without knowing anything else about it. How cool is that? Now, checking equations is super useful, but this is where dimensional analysis goes from a neat trick to a legitimate superpower. We can actually use it to figure out the form of an equation completely from scratch.
So let's get ambitious. Imagine we lived before Newton and we didn't know his law of universal gravitation. Could we still figure out the formula for a planet's orbital speed just by using logic and dimensions? Let's find out.
First, we'd make an educated guess. The speed of a planet probably depends on the star's mass, right? And the size of its orbit, and probably that fundamental constant that governs gravity itself, which we call g. So we can propose a relationship. We'll say that velocity v is proportional to g, m, and r, but we don't know how. So we just raise each one to an unknown power, x, y, and z. Our entire mission now is to find those three exponents.
Okay, this is the magic step. We replace every single term with its fundamental dimensions. Velocity becomes L(t negative 1). The gravitational constant, g, is a weird one, but its dimension is m negative 1, L3, t negative 2. Mass is just m, and the radius, r, is just a length, L. And suddenly, our physics problem has turned into a puzzle with only 3 letters, m, L, and t. Now we just use our golden rule. The dimensions on both sides have to match perfectly. So,
The total power of mass on the left must equal the total power of mass on the right. Same for length, same for time. This gives us 3 simple little equations we can use to solve for our 3 mystery exponents.
And when you solve that little system of equations, you find the values for those exponents. X and Y are both 1/2, and Z is -1/2. We've cracked the code.
So we just plug those exponents back into our original guess. And what do we get? Velocity is proportional to the square root of g times m divided by r. This is the correct form for the orbital velocity equation. We literally just guessed a law of nature using nothing but logic and consistency. That's incredible.
So, let's take a step back. What have we really learned here? Because this is so much more than just a neat party trick for physicists.
The thing is, this is a tool for thinking. It's like a built-in error-checking system that forces your work to be physically consistent. It helps you see the deep connections between concepts like energy and mass and time. And really, it's a mindset. It's about demanding logical consistency, and that's a skill that applies far, far beyond any physics classroom.
It really makes you wonder, doesn't it? If a rule as simple as you can't add apples and oranges can help us decode the orbits of planets, what other simple, powerful principles are just hiding in plain sight, waiting to explain the complexity all around us? It's something to think about. Thanks for watching.